Okay, here we go. Oh, that's not. Okay, there's the limit definition of a derivative, right? Correct? That's the limit definition of a derivative. That's f primes. So if I say f of x is equal to sine of x, we can then find the derivative of the sine function. We can't use power rule because sine is a special type of function. So we have to do something else. So what we're going to do is use this limit definition. So I put this, whatever's in brackets goes in for x. So you get the limit delta x goes to 0 of sine x plus delta x minus f of x, which is just sine of x, all over delta x. Are we okay? Oh, does everybody understand that substitution? All right. Now, you got to think back to, if you're in my Math 12 class, it was it was January. This is a sine function with two things being added together. So that is where is it? Math 12 formula sheet, open up. Yeah, it's this one right here. It's an addition identity, right? Remember this? So it's sine A cos B plus cos A sine B. So that's what we're going to do. So we're going to break it up and get, we're writing in white apparently. The limit is delta x goes to 0 of sine x cos delta x plus cos x sine delta x. And there's a minus sign on the end. And it's all over delta x. I like her position. That's the addition identity. You don't need to remember that. I'm not going to ask you to redo this. Okay. I'm going to manipulate this. The top of it, I'm just going to move this sign here to this position here. Okay? Okay, so all I did was move that negative sign to the middle, essentially. All right. Then what did I do? So I'm going to factor out, I should have moved it around. Oh, well, whatever. This will work. Okay. See this bit right here? Can I take anything out of there? You can take a sine x out, right? Does everybody agree with that? Okay. I am going to take a negative sine x out, just because. All right? We will. So if I pull a negative sine x out, I'm left with, now, this part here will become positive 1, and I'll be left with minus cos delta x. Is that okay for everybody? Okay. And it's over delta x. Now. You want to break up the two functions. Split it through the middle here. So the delta x goes to both of these. So I'm going to get... Oh yeah, I'll do that after. And because it's limits, I can write them as separate limits. Okay? Are we with me? Are we with me? Are we with me? I'm never going to ask you to repeat this. Sometimes some profs I've seen make you memorize this and puke it out on a test, but I'm not going to do that.
Oh, you're saying we're not going to have to do this every question?
No. Unless you really want to.
No.
Okay. Are we okay so far?
We're okay.
All right. Do you see this? What is that?
Zero.
That's one of this. That's one of the special limits, right? So that is just negative sine of x times 0, which is 0. Then you look at the other side. What is this? So what do you, I should say plus cos x times 1. So what is the derivative of the sine function? It's just cos x, whatever's left, right? 0 makes all, this is 0. This is a constant because x, this is delta x that's changing, so this is essentially a constant. So if this goes to 0, that wipes all that out. This is the limit as delta x goes to 0. This becomes 1 times cosine. The only thing you're left with is cosine. So the derivative of sine is cosine. So the derivative of sine is equal to cosine. You need to remember that one. Wow, we use it so often. It's pretty straightforward. What's the derivative of the cosine function? It would be nice if it was that. It's negative sine x. All right. The derivative of the sine function is cosine. The derivative of the cosine function is negative sine of x. Derivative of cosine is negative sine. You can go through the same process for this cosine derivative and you'll see it spits out negative sine x, but we're not going to do that. Okay, so having those, you can now do trig derivatives. So if y is equal to 2 sine x, what's y primed? 2 cos x. Because you don't care about constants, right? Constants you can just pull out, forget about them, find the derivative of the sine function, and there you go. We can also do things like this. We'll come back to that. What's the derivative of that function? Plus sine x, because the derivative of cosine is negative sine. There's already a negative in front of it. So it's sine of x. And those are the basic derivatives for sine and cosine. All right. Right now, they're not going to get any yuckier than that. Next week, they will. Doesn't that make you feel good? Here's what I'd like you to do. We'll do it. Don't worry. I'll do squeeze theorem. 19 to 23 and 51. And just because you asked for it, no. And we'll do 61. All right, that's it. Oh yeah, that'd probably be helpful, wouldn't it? Page 114. All right. Matthew, why do you really want me to do squeeze theorem today?